Hello, in this video, I will introduce factoring a polynomial using rational zero theorem and synthetic division. So this is a complete brand new topic. Uh, it's it's really the last resort you want to do. I mean, if you can do the other previous techniques we learned from the class, I would definitely use this. But yeah, this is definitely a way to factor a polynomial. So rational zero theorem and synthetic division is just another technique to factor a polynomial. Like I said before, it's the last resort when all other techniques you learned from this class failed. Okay. So what is the rational zero theorem? It's all your possible zeros, your possible x-intercepts, right? So it's pretty much plus or minus p over q, and I will explain that in an example. P is the last term, or the constant of the polynomial, and q is the coefficient of the highest power. Both p and q are positives. So yeah, let me show you an example. So on example, it says find all possible zeros. Use rational zero theorem. So they're asking what are your possible x-intercepts, your possible zeros. They're not asking you to factor. We just want to know your possible zeros. So let's first figure out what our p is. My p is going to be the constant, usually the last term, and our constant is 3. If this was a minus 3, don't even worry about the minus. It's always going to be positive, okay? And then what I'm going to do is figure out what are all the factors that makes up 3. You could use 1 and 3, and believe it or not, you can also use positive 1, negative 1, positive 3, and negative 3, right? So I'm just going to use the plus or minus. That means plus or minus 1, plus or minus 3, etc. Okay. And then what would be your Q? Your Q would be 2. And the reason why it's 2, it's the coefficient of the highest power. So our highest power is 3, but the coefficient or the number in front of x is 2. Okay. So what are all the factors of 2? 1 and positive, 1 and 2, right? That's all the factors that makes up 2. We're going to use positive and negative, so we're going to do plus or minus, right? And so now we got to do rational zero theorem. So rational zero theorem is p over q. So that's going to be plus or minus because we have positive and negative roots. So what we're doing is dividing p over q. So 1 over 1 is 1. 1 over 2 is 1/2. And then 3 over 1 is 3. And then 3 over 2 is 3/2. So these are your possible zeros. Now, it looks like 1, 2, 3, 4. We actually have 8 because remember the plus or minus. So in reality, you don't have to write it out like this because we have that plus or minus. But in reality, it's actually 1, negative 1, 1/2, negative 1/2, 3, negative 3, 3/2, and negative 3/2, right? So these are all your possible zeros. These are not, once you find out your possible zeros, then you're going to do synthetic division. I will go over the synthetic shortly. And if it gives you a remainder 0, that means it's an actual 0. Okay, so this is all rational zero theorem, and it's just finding your possible zeros. Okay. I am going to move on to the next slide. So synthetic division. Once you found all the possible zeros by using rational zero theorem, you will use synthetic division to actually determine if that specific zero is actually a 0 or the x-intercept, right? When they say 0, they mean x-intercept. If you get a remainder of 0 when applying synthetic division, that means it's an actual 0. So I will go over synthetic division right now. So determine which are your actual zeros by applying synthetic division. So yeah, so let's first find out, wait, this is the example from the last section, right? So our possible zeros, because this was from the previous slide. So our possible zeros by using rational zero theorem was plus or minus 1, 1/2, 3, and 3/2, right? Because we applied the rational zero theorem, right? So our P was 3 and then our Q was 2, right? Okay, so now what we're going to do is we're going to do synthetic division. What I would do is make sure this polynomial is in order. If you're missing a power, just replace it with 0. So we have a power 3, 2, 1, and a constant. So it looks like we're not missing anything. So how do we do synthetic? So it's going to be put this little box. And then what we're going to do is only use the coefficient. So starting with the highest power 3, we have a coefficient of 2. Starting with the power, and then 2 has a coefficient of 3. And then 1 has a coefficient of -8. And then the constant is 3. So this is tedious. You literally got to try. There's no like shortcut. There's no secret. You just got to try one. And if it gives you a remainder of 0, it works. So let's try a positive one. So what you're going to do is on the first term 2, you always put a placeholder under the first term. So then you add those two terms. So what's 2 plus 0? 2, right? Then what you're going to do is multiply 2 by this number. So what's 2 times 1? 2, right? And then add the two terms. So 3 plus 2 is 5. And then 5 times 1 is 5 times 1 is 5. Put it here. And then add these two terms. What's -8 plus 5? -3. -3 times 1 is -3. Okay, good. It works. And I just literally picked it. I didn't, there was, yeah. So what that means is 1 is an actual 0, or 1 is your actual x-intercept. So you could say 1. And then what, we got to find all our zeros. The highest power means there's exactly 3. And sometimes a 0 can repeat. So what do I do with these terms? 2, 5, -3. So if you want to start factoring, if 1 is an actual 0, in factor form, it would be x plus 1, right? If 1 is an actual 0, in factor form, it would be x plus 1. And now, so you have 2, 5, and -3. So those numbers are your coefficient of your newest highest power. So we have 2x, and then we're not going to use the power 3 anymore. We're going to use the power 2 plus 5x to the power 1 minus 3. So how do you, we want to completely factor. 2x squared plus 5x minus 3 can be factored. How would you factor this? Well, there's two ways. You can either try synthetic division again, meaning your p is 2 and your q is -3. Or we could try, because our a value is greater than 1, we can do bottoms up factoring, right? I don't like doing synthetic because it is time consuming. So let's first try bottoms up. If it works, and if it doesn't, we can do rational zero theorem. So if you recall, first step of synthetic is rewrite as if the 2 doesn't exist. So it's going to be x squared plus 5x. Then what you're going to do is multiply 2 by the last term, so that's -6. Now this does factor nicely. what two numbers multiply -6, and when added gives you 5, 6 and 1, and I'll use +6 and -1, right? Then what I'm going to do is, with bottoms up, you divide the 6 and the -1 by the original power 2, coefficient. So 6 plus 6 divided by 2 is evenly 3. Now, -1/2 is a fraction that cannot be reduced anymore. So what you're going to do is put the 2 in front of the x. So that's 2x, and leave the numerator alone. Okay, so this is the most factored it can be. It cannot be broken down anymore. But is this our answer? No. If you look at the direction, determine which your actual zeros. So you're actually finding your actual zeros. This is just getting it completely factored. So there's just one more step. To find your zeros, to find the x-intercept, you set y to 0. So it's going to be 0 equals to x plus 1, x plus 3, and 2x minus 1. So your actual zeros are going to be -1, -3, and +1/2. So how did I get these? What I did was I literally set each equation to 0. Some people can do it in their head, but if you forget, sometimes it is simple enough where you can do it in your head. So for the first one, it's like x plus 1 equals to 0, x plus 3 equals to 0, and then 2x minus 1 equals to 0. And then you literally solve for x. So this subtract 1, so it's -1, subtract 3, you get -3. And then over here you have to add 1 to both sides, and then you have to divide this by 2. So those are your answers. Your actual zeros are -1, -3, and +1/2. So this is very helpful when you're graphing polynomials in your college algebra class. Okay. So yeah, go ahead, and that was a lot to grasp, but go ahead and write down. And then let's see if there's another. If we're going to start doing examples, let me check. Yes. Okay. So let's stop here. We'll start doing examples. I don't want to make these videos too long, so I'll end right here.